chat today with a student that said, hey, if you're going to make a 6-hour tutorial video, that's great, but how do you expect us to complete a test that we're only given 50 minutes to complete if your tutorial video is 6 hours or 3 hours? And I really listened to the student and I said, okay, let me see if I can do this. All right, students, so we're going to keep ourselves to time here, and you have 50 minutes to take this test, so let's jump over to a timer and start it. Okay, so here we go. 3, 2, 1, start. Okay. All right. Solve the absolute value equations. Remember to check for extraneous solutions. Okay, so I'm going to do this as if I was you, and that was the request made. So what I would do, I would divide both sides.
Teachers, pardon the interruption.
Sorry for the interruption. So now we divide both sides by 2, and remember that the inside doesn't get changed, so we just divide out the 2, and now I guess I better make this a little bit bigger. I have the absolute value of 3m minus 2 equals 4. Okay, so now that I've isolated the absolute value on the left side, I can do the little split into 2 different equations, and remember it's 3m minus 2 equals 3m minus 2 equals. Since we don't know whether the original variable was positive or negative, we put 4 and negative 4. Okay, so we negate the second equation there. So now I just add 2 to both sides, plus 2. And I've got, again, sorry for the interruption there. So now we have 3m equals 6. And what I would do is divide both sides by 3. Apologies again for the interruption. Divide both sides by 3, and we have m equals 2. That's one of our possible solutions. And here I'm going to add 2 to both sides. Now I have 3m equals negative 4 plus 2 is negative 2. And I'm going to divide both sides by 3. Cancel, cancel. M possibly equals negative 2 over 3. Now, we didn't validate to check to see if there are extraneous solutions. And so the way you do it is very simple. You just plug it into this. Okay, that's how you check. So we're going to check our first solution here, which is 2. So that means I'm going to do absolute value of 3 times 2 minus 2, absolute value equals 4. The question is this true? Absolute value 6 minus 2 equals 4, absolute value 4 equals 4, 4 equals 4. It's true. So this is a valid solution. Now we're going to check to negative 2/3, okay? So what I've got is absolute value 3, open parentheses, negative 2/3, close parentheses, minus 2, absolute value equals 4, question mark. Well, let's see, 3 times negative 2, absolute value of negative 6 over 3 minus 2, absolute value equals 4, question mark. And then negative 6 divided by 3 is negative 2, so I've got negative 2 times 2, absolute value equals 4, and then I've got absolute value negative 4 equals 4, again question mark, question mark. The absolute value of any negative number is positive, so the absolute value of negative 4 is 4, so 4 equals 4, check, right? So both of them are valid. So what you would write in your solution is you would do open brace, and I like to do least to greatest here, negative 2 over 3, comma, 2. Okay, so now we've shown everything. We've got our solutions here, and we've got our checks here, check 2, check 3, so we validated for extraneous solutions. Okay, there weren't any. So now we'll move on to number 2. And here we are in number 2, find the inverse. We're finding the inverse, and here's the given function. So the given function is f of x equals 3x minus 5. So what you want to do is just cancel out that f of x and rewrite it as y equals 3x minus 5. Okay, now we're going to move down here. Okay, and what I'm going to do now is swap the positions of the x and the y. So instead of y equals 3x minus 5, I'm going to write x equals 3y minus 5. And now I'm just going to solve for y. Let's see, add 5 to both sides. You can't add 5 to x, so it's just x plus 5 equals 3y. And then divide both sides by 3. And you come out with y equals x plus 5 over 3. And you see that's this. Now, we didn't actually check to make sure that that's a true inverse, but let's assume that we don't have time to do that, since that does take a little bit of time. And we'll move on. List the transformations of the absolute value function in comparison to its parent function. So if you don't know what the parent function is, you can't evaluate anything. So we have to draw the parent function. I mean, this is what you would do and what you should do. So let's draw the parent function. Oops. I'm going to draw this parent function here. And then we'll draw and explain what's happening. So the parent function of an absolute value, this is going to be f of x equals absolute value x. Okay? So the parent function is, what's really going on here is you have the equation y equals x, right? So I'm going to plot that real quick and show you how we get the parent absolute value function. So let me draw this in. I'm going to draw just a 45-degree angle passing through the origin. That's y equals x. And here's how that parent function is formed. So now everywhere along this blue line, x is positive. All the x values are positive. But then, past the origin, suddenly we change to negative x values. Okay, so look at this. So that's like the line, right? That's y equals x. Everyone knows this. And so how do we get the v? Well, remember, absolute value negates all negative numbers. So all these negative numbers here, you know, all the negative x values, they just get turned positive, which actually ends up reflecting across the x-axis this red line. So let me show you what that looks like. So we're going to reflect across the x-axis. It's going to be a 45-degree angle. Okay, and I'm going to show you, if you reflect all those negative x values, here's that blue, look what you get. You get what looks like an absolute value function. And that's it. That's exactly how that's formed. So there's the parent function, f of x equals absolute value x. And now we're just asked to find out what is happening here. Okay, so we've got all these transformations occurring. Well, let's identify what those transformations are. This means go up 1 unit. Okay? Now this means move or shift or translate to the right, okay? The right 4 units. Okay? And this right here is the slope of the resulting function, the a value. And so what you have here is stuff nobody explains to you. The standard form of one of these absolute values, and I'm not going off on a tangent, I'm just telling you what you need to know in order to do this, and you just haven't been told. The standard form, f of x, is equal to a absolute value x minus h absolute value plus k. Okay, so the vertex, we need to find the vertex of this function, is going to be just at h comma k. So the vertex of the absolute value is at h comma k. So notice that it's minus h, minus 4. So the h value is 4 and the k value is positive 1. So the vertex of this function is located at 4 comma 1. So let's go find that. Let's use a different color. Let's use red. Okay, we'll call this this is like, we call it g of x, so you understand the difference, right? Because I called this f of x. It doesn't matter. So anyway, let's move to the right by 4. Let's actually plot the vertex first, okay? 4 comma 1. So 1, 2, 3, 4, up 1. So there's the vertex of the absolute value, okay? And now we have to figure out what else happened. So you see I did it. I moved over 4, which is to the right. This negative symbol always confuses people. And then I went up 1. So that's like the bottom, right? Now we got to figure out, what does this 3 do? Okay, well, it just means that the slope is 3 over 1. That's all it means. Okay, so from this point, we're going to rise 3 and run 1. Okay, so we'll go from here. I'll use a different color for the rise of the run, make it real small. So we're going to start at that point and go 1, up 2, up 3, over 1, right? And so here we go. There's a point. Now maybe you do the same thing the other direction, because absolute value mirrors itself, right? But we'll plot another couple of these points so you can kind of see. Up 1, up 2, up 3, over 1. That's another point. Plot that. Okay. And you can just reflect, right? So instead of going rise and then run right, rise and run left, because it's a mirrored function, right? So let me show you exactly what to do. So you're gonna rise up and then run to the left one, right? So it's gonna be like here, and then you're gonna rise up 3 more and then run to the left one. You're getting the idea, right? This is the shape. And so let's take the ruler to it and kind of make this a shape. I'm going to use red. So here's my new absolute value function, g of x. Okay. And just compare the two. What happened? List the transformations. What happened? Did it... First, it moved, right? So it moved over 4. Let's just write them out, because now again, this is what I'm not doing anything extra here. This is what was requested by students. Don't go off on your little digressions and spend 5 hours. So what happened here? Step 1, we moved. So we could say trans, which means translate. You could also use shift or moved or whatever. Translate right. Okay. You could also just use this arrow, okay, 4. Then what? 2. We moved up 1, so that would be a trans or shift up, right? 1. Then what? Well, if you look at this, this is called a squeeze. You know, we squeezed it, and we'll just write. We did a squeeze. This is kind of childish. I would have instead preferred that we say, well, we identified the vertex of the new function, and it was, you know, over 1. But anyway, that's what you would write. Those are the 3 transformations that occurred. We had a right translation of 4 units, a vertical translation of 1 unit, and then, or let me use shift right 4, shift up 1, and then squeeze the function. Don't say squeeze by 3, because that really doesn't mean anything. Just say it's squeezed, you know. And then if you really want to explain yourself, you might want to say, you know, slope of f parent function, well, slope of parent function f of x equals absolute value x equals 1. The slope of it is 1. The new slope, you know, of what we call g of x was 3. Okay, so that's a squeeze. All right, well, okay, we're done with number 3. Okay, moving on. Okay, we're still trying to be on time here. Let's see where we are on the timer. Oh boy, 15 minutes. Okay, so solve the absolute value, check for extraneous solutions. Oh dear. So you know, again, they've given us an absolute value equation, and then no space at all to work it out. But that's okay. We'll work out what we can, and then we'll move over. So what do I got to isolate. I have to get this by itself. I have to. Okay, and then I have to make sure that it's equal to a positive number. So what I'm going to do first is subtract 7, and now I have absolute value 5x minus 1 equals negative 4. Okay, now right there, bingo. Uh-oh. Okay, so this is what I would do. I would say no solution. Okay, D, because the absolute value can't be equal to a negative number once it's isolated. But if it's not isolated, so there's 2 things here. Why is it no solution? Okay, first of all, it was an integer, right? It's just a whole number. It's not a variable. That's how you can make this. If this had said, for example, negative 4x, you could not have made that conclusion. But just because it is set to a negative number, so neg int means like it sets the negative number, there's no solution. Moving on. Okay, here we are in number 5. What is the equation for the absolute value function below? Well, that's why I'm so glad we did all this, right? Because now you know what is the parent function, because you need that before you can define what occurred. So first, I recommend drawing in the parent function. Again, this wasn't shown to you, so what I'm going to do is let me just define here. I'm going to write down whatever. P of x is parent function of x equals absolute value x. Okay, so now let me draw it in. So it's basically just that 45-degree line passing through the origin. See, what I'm trying to do is get it to pass through all these points here. We call these lattice points. The gray lines intersecting in the background. You know, so there's your, remember, we're only doing positive numbers, so don't keep going. Stop there. Stop. Because we're going to negate all those negatives, which make them positive. So we're going to go here and draw 45-degree line. Protractor really help you here. See, look at that. Boom, boom, boom. Draw it in. And now you know. Now you can work with it, because now you can see what happened. So first of all, notice that these lines are parallel. So what is the symbol for parallel? Parallel, 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 parallel. So there was no squeeze. It's got the same slope. Okay, so same slope. Okay, well, what was the slope here? The slope here was 1. So we know the slope is 1. You have to know this basic formula. Remember f, let me use a different number. This is just like the standard form. Okay, standard form is going to be they keep giving me f of x, so I'm going to say like s of x, right? Standard form is equal to a absolute value x minus h absolute value plus k. Okay, so if that's negative, that's a right shift. If there's some number here, that's a vertical translation, either up or down. So let's see, did we have a vertical translation? No. So we just had a right shift. So we shifted right. You can literally read how we're about to make this equation. So let's write the equation. So we know, what do we know about our equation? We know that this is 1 because it's the same as the original because the lines are parallel. Okay, so 1 absolute value, and we're in terms of x, so x, we have a shift of shifted right by 2. Okay, so that would be x minus 2, right? Absolute value. And then do we have a vertical translation of any kind? No, so it would be like plus 0. Now can we simplify that? Yeah. And I'm so sorry for that. I have no control. So now we're ready to like write the function, you know. F of x equals absolute value x minus 2. Nothing else happened. You're done. So this is absolute value x minus 2. You're done. We're done with number 5. Okay, so number 6 is just to list the transformations. Okay, well, all the only transformation was a right shift of 2 units. End of story. What is the domain? Okay, look, the domain is infinite. You could plug in any x value, you're going to get a defined, mapped y value. Okay, so the domain would be, there's many ways to write this, so I'll write it a couple ways that you might know. That you could do open parentheses, negative infinity to positive infinity. That's, you know, that notation. Or you could have done negative infinity less than or equal to x less than or equal to positive infinity. Or you could have said the really hard one, the set builder, the set of all x which are elements of the real number system such that x is between negative infinity and positive infinity. So you can just choose one way to write that, you know. Or I guess you could have also just written all real numbers. And that's what that R means. So all real numbers, this is the symbol R. What is the range? Well, the range definitely isn't all real numbers because the bottom is right here. This is the bottom of the range. So let's define that. Let's draw that in. Okay. Here's the bottom of the range. It can't go below 0 on the y-axis. So let's go down here. But look, it goes up forever and ever. So the range is 0 to infinity. So here we go. Range. It begins at 0. So using this notation, you would do a bracket because that means it includes 0, 0, comma, infinity. Okay. There you go. This is the way you would write this. You would say 0 less than or equal to y less than or equal to infinity. And then you would say the set of all y that are elements, this is elements of the real number system such that y is between 0 and infinity. Okay. I think you might have to put 0 less than or equal to y less than or equal to infinity. I don't know. You could also have said it in English as all real numbers greater than or equal to 0. Many ways to write that. So what's the vertex? Well, there's the vertex right here. That's 2, 0. So vertex is equal to 2, 0. Well, that was easy enough to read here, right? Because now we know that the h, k is the vertex, right? H, k. Well, here you go. There's h, and there's k. So a lot of power in knowing the formula, right? So the vertex is at 2, 0. So we're going to go here and put 2, 0. The axis of symmetry is always easy. Whatever this number is, you just write x equals that. Okay? So x equals 2. We are done with number 6. Okay, I'm taking the test like a student. Okay, here we go. Oh boy, let's see where we are on the time. 25 minutes, okay. So let f of x equals negative 3x minus 7 and g of x, and this got this quadratic. It wants to know f of g of negative 2. This is a composition of functions problem. Okay, composition of functions. Okay, so first we want to do the composition of f of x and g of x. None of this nonsense about plugging numbers in. So here's how that looks. F open circle g close of x. Okay, now what we're going to do, start with f of x. So you're going to use the framework here. And the only thing you're going to change is that x. And what are you going to change about it? You're going to put this whole thing in here. Okay, that's all you're going to do. You use open parentheses and just stick it in there. So it's really not that hard to do this step. And this is the correct way to do it. End of story, right? So you got negative 3 and then open parentheses, and now we're going to write x squared plus 5x minus 3, close parentheses, minus 7. Okay, so now distribute the negative 3. Okay, so remember, I'm still going to write the composition of f and g of x equals negative 3x squared. Anybody tells you that you don't have to do this step and that you should just plug in the numbers is wrong. Okay, and you can tell them I said that. So now negative 3 times 5x, that's going to be negative 15x. It's, you know, what that is that's called cheating / shortcut / plugging it in. It's not anything. It's not mathematics. Now you got negative 3 times negative 3. That's positive 9 minus 7. All right, keep going. Composition of f and g of x equals negative 3x squared. We're just simplifying here. Minus 15x. And then plus 9 minus 7 is plus 2. There you go. Now you got your composition of functions. Now you can plug in negative 2. So now what we do is f of g. So, sorry, composition, not f of g. The composition of functions f and g of negative 2. Now here we go. So we're going to write negative 3, open parentheses, negative, oh come on, open parentheses, negative 2. Okay, everywhere you see an x, you're going to plug in parentheses, I should add. You should put it in parentheses. Okay, negative 2. All right, so let's keep going. Remember to square it right here. Minus 15, open parentheses, negative 2, close parentheses, plus 2. Now you just simplify and solve. Work PEMDAS. Remember PEMDAS? You got to do it. You got to do it because first you got to do the exponent here. So you got to do negative 2 squared. So what's negative 2 squared? No, well, anything squared is positive, so 2 squared is 4. So you got negative 3 times 4. Let me write that a little bit clearer. Negative 3 times 4. Gosh, doing this way, I feel the time pressure that you folks are under. And what you're really doing here is plus negative 15. There's no such thing as subtraction. Times negative 2. Okay. Plus 2. All right. So remember, now we're on parentheses. So let's go. Here we go. Negative 12. Negative 3 times 4. And then negative 15 times negative 2, that's plus 30. Plus 2. Okay, here we can do it all together. So 30 plus 2 is 32. 32 minus 12 is 20. Right? Okay, so I would write f of, using their notation, f of g of, you don't need this, parentheses, of negative 2 equals 20. That's the answer. So f of g of negative 2 equals 20. In other words, when x is negative 2, y is 20. You know, I could go to Desmos and prove that, but we're doing this on a timer, so that's the end of number 7. See number 8. Where are we on time? My gosh, 31 minutes. Okay, so now you've got these two functions and you have to add them together. So first thing you have to do is add them together. So what we're going to do is open parentheses f plus g of x. None of this plugging in stuff. Please stop that. So now we have parentheses x minus 9 parentheses plus parentheses x squared plus x plus minus 7 parentheses. Well, we're adding, so we really don't need the parentheses, so that's just x, and I'm going to put a 1 in front of it. 1x, okay, it's going to help you in a minute, minus 9 plus 1x squared plus 1x minus 7. Now identify like terms. Okay, here, negative 9 and negative 7. Those are like terms. What else is like term? How about 1x and 1x? Okay, combine like terms. So remember, we put this guy goes first, okay? Right here. He goes first. So, because he's got the highest exponent, so he gets to go first. So we're going to write f plus g of x, f plus g of... I feel the time pressure, guys. I really do. So I've got x squared. I feel like I'm going to make a mistake. Plus 2x. This was good exercise. Whoever, you know, there is somebody, I don't want to name him, but he's the one that told me to do it, like suggested we do it this way. And it's good. It's just really teaching me what you guys go through. And then negative 9 plus negative 7 is negative 16. Gosh, just having to do this on... so now we're going to evaluate. So now we're done making the function. So now we're going to evaluate it. F plus g of negative 2. So basically everywhere there's an x, we're going to plug in a negative 2. And remember, we're going to do that in parentheses. Okay? So we're going to put in here a negative 2, and we're going to put in here a negative 2. All right, here we go. Ready? Open parentheses, negative 2, close parentheses, squared, plus 2, open parentheses, negative 2, close parentheses, minus 16. All right, so here we go. Let's do it. Negative 2 squared is 4. 2 times negative 2 is negative 4. So 4 minus 16. Okay, well 4 minus 4 is 0, so this equals negative 16. Therefore, we should just write it all in. F plus g of negative 2, f plus g of negative 2 equals negative 16. So, you know, this is the x value, right? This is the y value that goes with it. Okay, moving on. This is it. We're done with number 8. Okay, here we are in number 9. Remember, there was an error, and that's why I gave this one to you, because there was an error. This should have read, on A, it should have been negative 1. And I do want to give a shout out to, I won't use last names, right? Eric. You know who I'm talking about. Eric. And if Eric's watching this, great job, man. You identified it. So this should have been a possible answer choice. All right, so we got it. Let's go through the process. All right. So timer's still running. So do I have the absolute value isolated by itself on the left side? Yes. I can't do any kind of like analysis because there's a variable on the right, so I've got to do my branching tree structure. So branch the tree. Branch that tree. So we're going to have two equations. So what I like to tell people is just write 5x, drop the absolute value bars, write 5x minus 2 equals. And then over here, 5x minus 2 equals. All right, now, remember, we don't know whether x was positive or negative. So you need to consider two different options for 7x plus 14. So 7x plus 14 has got two different options. It could either be positive 1. Okay, so now what I'm trying to tell you here is, and I just did have a conversation with someone, so when we get to look at the final time, let's subtract 3 minutes, okay? Because I had to pause the video to have this little conversation. Anyway, so we multiply 1 times 7x plus 14. Oops. You guys always hear me saying negate the right side, and it always seems like, why does he say it that way? It's so weird. Well, here's why I'm saying it, because now we have to negate the right side, and the right side is an algebraic expression. Okay, so now this becomes more complicated. So here's how you do it, and I would write this down. So what you're going to do is distribute, multiply that negative symbol. You know, virtually every student failed to do this. You have to distribute, multiply that negative symbol. And so now your other right side here is going to be negative 7x minus 14. Okay? And that was the key. So here are your two things, right? We know that this just means 7x plus 14. Nothing changed. So here you write 7x plus 14. Just what's written here, okay? Same thing. And then here you negate it, right? Multiply this whole thing times negative 1 is what you're doing for the other one. So now you're going to have negative 7x minus 14, okay? Now you solve both problems, okay? So let's solve for x on the left. It's minus 7x minus 7x. What do we get? We get negative 2x minus 2 equals 14. Now add 2 to both sides. I got negative 2x equals 16. Divide both sides by negative 2. Negative 2. Cancel, cancel. X equals possibly negative 8. Remember, we have to check for extraneous solutions. So now, let's do this one. So here I'm going to add 7x. Add 7x. Cancel. Now I've got 12x minus 2 equals negative 14. And I'm going to add 2. Add 2. So now I have 12x equals negative 2. Wait a minute. What did I do wrong? Oh, I put plus 12. Let me stop my mistake before I make it. And plus 2. Sorry, I got it. I was thinking ahead one step. So this is negative 12. See? So now we're going to divide both sides by 12. Cancel, cancel. X equals negative 1. Okay? X equals negative 1. So these are our, I'm going to put up here, possible solutions. Negative 1, or sorry, we're doing it in order. Possible, okay, not final. Possible are negative 8 or, and, right, and or negative 1. Yeah? So now we have to test them. So where do we test them? Well, we just plug it in here. You plug it in here. So you can do it in your head, right? What is 5 times negative 8? We're going to test negative 8. 5 times negative 8, that's negative 40. Negative 40 minus 2 is negative 42. The absolute value of a negative number is positive, so it's 42. Okay? So that side's 42. Let's just write that little note here. Okay, got 42 over here. 42 equals... Now what about 7 times negative 8? That's negative 56. What's negative 56 plus 14? Well, that's going to be a negative number, but what's 56 minus 14? You can do it in your head. 56 minus 10 is 46. Now subtract 4 from 46. You're at 42. Negative, and you put a negative sign in front of it, so it's negative 42. So you got 42 equals negative 42. That's a false equivalence. Okay, so that means negative 8 is extraneous. All right? Which means, well, we have to check it first, but it means this can't be right. Right? That can't be right. So this is extraneous. Right? I'm just going to put a line through it. Now we'll try negative 1. So do it in your head. 5 times negative 1 is negative 5. Negative 5 minus 2 is negative 7. The absolute value of negative 7 is 7. So let's do this. So now we're doing 7. It better equal 7, right? So what's 7 times negative 1? Negative 7. What's negative 7 plus 14? It's the same thing as 14 minus 7. 14 minus 7, 7. So 7 equals 7. That is true, okay? Right? We know that's true by the identity property of equality. End of proof, okay? So that means that's valid. Therefore, it's A. And now you didn't know that, like, even if you got, like, some people come up to me and said, actually it was just the one student, but maybe some of you didn't come up to me, but you thought, what's wrong? I got negative 1 and I eliminated negative 8, but there's no negative 1 as an answer choice. So yeah, that's because there was a misprint on the test. So anyway, everybody got 9 right. So okay, so we're done with number 9. Okay, here we are on number 10, and this is, I believe, the final question. Where are we on time? Holy cow. I mean, remember, you subtract 3 minutes for me, but still running up against the clock. I mean, and I'm a math teacher. So do I already think this test was too long? Yes. Raul thinks that applying the absolute value symbols to a number results in the opposite of that number. For example, he thinks the absolute value of 3 equals negative 3. Write a short paragraph to identify and correct Raul's mistake. So, you know, looking at the time, I don't have time to write a short paragraph. Let's see how long it takes me. So how would I answer it? Because then I want to talk to you a little bit. So what we should say is that we should say something like this. The definition of the absolute value function is that all inputs to the function must emerge or output as positive values. Okay, you could say something like, I mean, I don't know. You could say something like, you could. I mean, I don't know if I'd write a paragraph about it. I think that's enough, right? That's one sentence though. I would draw a shape. You know, I would draw. If I was explaining this to somebody, I would draw. I would say, here, look, bro, look. And then I would do what I did before. I would say, look, let's graph, or let's say, I would say, consider y equals x, okay? And just draw it. But do it in a special way. This is what I would do for Raul. I'd say, look, bro. So you got this part. All the x values are positive in quadrant 1. And then we hit the origin. Let's just switch colors and keep drawing. Like, so that's the line for this this equation y equals x, right? Because the full equation, by the way, is y equals 1 over 1 x plus 0. So if you're doing the y equals mx plus b thing, the slope is 1 over 1, and the y-intercept is 0, okay, at the origin. So what you tell them is you say, look, whenever you get into this negative territory, which is actually all of this, I would draw. This is what I would do. You know, I wouldn't talk. I would draw. I'd say, look, bro, anything here, okay, all of this going forever, infinity, and here, this has to be flipped. You have to flip it here in this region, because now x is negative. This is the, you'd say, this is the region. This region, all x's are negative. Okay. You say, well, they can't be negative. The definition, you say, you know, but, you know, the definition is the absolute value of x equals positive x. So what you have to do is flip it. And then what I would do is I'd draw, you know. Pictures just tell 1,000 words, right? So in here, this is literally true. Get that 45-degree line and come right in here. And I'd say, so here's what you do. You're going to reflect that red line across the x-axis and just make it positive. Bingo. Okay? So then, you know, I would take like a highlighter or something, and I would say, so here's your actual absolute value. I'm messing it up. Here's your actual absolute value function. You see, it can only take on positive. It makes all x's positive. So, you know, that's how I would explain it, and I'd call it a day. I don't know how you're supposed to write at least 3 sentences about it, to be completely honest. But let's stop there. That's number 10.